1-7 Scatter plots. Our objectives today are construct scatter plots. The other is to interpret scatter plots. A basic definition for a scatter plot, for those who need it, is a graph that shows the relationship between two sets of data. In the table you see here, two sets of data. One is week, or the x-coordinate, and the one is score, the y-coordinate. Looking at the table, it's hard to see a relationship. We need something visible, and that's why we take the table and we graph the ordered pairs to give us something visual so we can make an interpretation. Let's do our first objective. Let's construct a scatter plot. Using this slide, the table shows the average SAT math scores from 1993 to 2002, and we're going to make a scatter plot of this data. First thing we need to do is determine which set of data is x-axis and which one is the y. It is a good rule of thumb that time, anything to do with time, is the x, anything other than that should be the y. You can see that right here. This is our x-axis, and it's clearly marked year, and our y-axis is clearly marked score. We need to build our graph based on the year. The year starts at 1993, but we also have to make sure that we put our origin in there. I know that's a big gap from 0 to 93, but that's what they give us. And we also need to look at our score. Our score doesn't exactly start at 500, but we want to start just before our first data set, and we want to end at least on or after, so we're going to stop at 516. The interval that I'm going to choose is every 2, because 503 to 516, that fits very well. Now, to show everybody that we have skipped a lot of numbers, 0 to 500 and 0 to 93, we'll put a page break. This little squiggly line right here informs the reader that there's some data missing, but it's not vital to the graph currently. Next up, we also have to have a title. Most of this information we get is directly from the information in the question, and the title is Average SAT Scores from 1993 to 2002. Now, the next thing to do is to plot the data on the graph, and you can see we already done that in blue. Now that we've made our graphs, we need to interpret them. So this would be our second objective. We basically have 3 types of relationships. We have a positive relationship, a negative relationship, and no relationship. You can either eye the graph and notice that the dots here in the first one are going up. Our x increases as y increases. Looking at our next one, you can see that as x increases, the y decreases. And then the last one, there really seems to be no relationship at all, or no pattern whatsoever. Some students or some teachers have said that you can just draw an imaginary line that follows the general direction, and you can get a feel that one's going up and one's going down. If you can't do that in certain graphs where you can't get a general idea where everything's going, you basically have no relationship whatsoever. Let's take what we just learned in the last slide, the relationships, and apply it to here on this slide. Determine whether a scatter plot of the data for the following might show a positive, negative, or no relation. Explain your answer. All right, you can see here we have a title, car value. The x-axis is age, years, and notice once again that time is the x-axis. The other will be our value, the y-axis. You can see that we chose years 1 through 9, and we started at 0, and the value goes out to 27, and that's thousands of dollars, and our interval is every 3. Now that I've developed the scatter plot, I am now going to interpret it. I've noticed that as the x increases or goes to the right, y decreases or goes down. That is a negative relationship. A negative relationship. Let's take another relationship and see what we can find. Determine whether a scatter plot of the data for the following might show a positive, negative, or no relationship. Explain your answer. They want us to look at birth month and birth weight. So I found my graph, my scatter plot. I notice it's birth weight. I know that my x-axis is birth month. It's the time. and then my y-axis is in pounds, and it has to do with birth weight. We're going to start with months. We have abbreviations for January all the way to December, and I notice on my y-axis we start at 0 and we go 1, 2, 3, so the interval is just 1. Is there a relationship? Is there a positive? Do you see, could you draw a line and does it follow the blue dots? No, it doesn't. How about this way? No, doesn't generally follow the blue dots. So if it's neither negative or positive, it's a no relationship. All right, our next slide. We have a biologist recorded the lengths and weights of some largemouth bass. The table shows the results. Make a scatter plot of the data. All right, so the first thing we're going to do is determine which one's going to be X and which one's going to be Y. I notice that there's no time, so I'm going to take length because I think length has something to do with the weight. So what we like to say is X is independent of Y, meaning that it's the length that determines the Y, but we'll discuss that later. All right, notice that we've titled it, and it has to do with largemouth bass. Since X is the length, we've labeled it. Since our graph, of course, in length does not start at 0 or anything close to 0, I'm going to start at 9, which is just below 9.2, and end at 20, which is just above 19.8. You can see that right here. So that gives me my 9 through 20, and my interval is just going to be at 1. So there you go. My x-axis is done. Now let's look at my y-axis. My y-axis, of course, starts at 0, and my first bit of data is pretty close to 0. So I'm going to start at 0 from here, and then I'm going to go all the way up to 5 or 5.5 here. My interval is going to be, and you can see that I start at 0, go 0.5, add another 0.5. So my interval is half, or 0.5. I've built my graph. I've labeled everything. I'm ready to plot, and you can see that my blue dots show the plotting. All right, now that I've plotted it and I've created my scatter plot, I'm ready to interpret the relationship. Does it have a relationship? And in the beginning I thought that length had something to do with weight. Now let's see here. I noticed that the x-axis is increasing, going this way, and so is the y-axis. And if I were to draw a general line next to the blue dots, it seems to be going up. So yes, it is a positive relationship. And it kind of makes sense. The longer it is, the more it should weigh. Our last slide, still using the same coordinate plane and the same information that we plotted, they're going to ask us to predict. What they're going to ask us to do is find information that's not on the graph. What are they asking? They want to know what the weight of our bass is if it measures 22 inches. If you notice that our length does not go past 20, so we're going to have to extend it a little bit. I'm going to say that's about 22. We're also going to have to remember that our relationship is positive, so it's going up. So our answer has to be greater than our last observation, which was 4.8. So I'm just going to go like this, and knowing that my relationship was positive, I'm going to have to make a prediction about my weight based on this. So somewhere in this area right here, where the arrow is pointing, is where my prediction I think is going to be. So I'm going to say my weight is going to be greater than 5 pounds.